Okay, guys. So this will be the video about the acceleration due to gravity. In here, you are going to be working with a couple of simulations that will allow you to investigate and verify the value of gravity, the acceleration due to gravity. So if you open this remote file, you will find the objective and the procedure for both experiments. Now, in this simulation, you again are going to use exploration physics, and you're going to go to the free fall simulation. Once you are there, you are going to be working with a small ball and a large ball, and you're going to be doing basically what we do in the lab. You're going to be dropping a mass. And regardless of the mass, you're going to see that it will take certain time depending on the height. And the idea is to plot the vertical distance as the ball approaches the ground as a function of time. Now, if you were doing this in the lab, it will be a bit more simple because we use the Pasco device and we have automatic timers. So that will be that will make the experiment more simple. Now, you can do something similar here, but you need to read the time from the graph. And that's what can bring you or can introduce some level of uncertainty. So you should discuss or mention that when you write the discussions and conclusions in your lab report. Now look at all the parameters. We're going to disregard the wind speed. We are going to disregard air density, and we're going to leave gravity as it is. The only thing we're going to change is the height, the radius, and mass for the large ball. Okay? So it's pretty straightforward. You are going to open the software. And once you open this guy, make sure you go to free fall. And then make sure you check this off because you don't want the ball to bounce. You don't want that. That will make your readings harder to take. So this and then look what happens. Okay. And then, of course, it's going to stop here on the ground. Keep in mind that those red dots are the position versus time. So when you do this in the lecture, you will know that the y position is for a constant acceleration is equal to y initial plus initial velocity times time minus 1/2 gravity times square. This is a parabola opening downwards, and the factor of the square of the time, t squared, is half the gravity. So we are going to plot the y position or the height as a function of time squared. Because when you do that, you can easily find the slope of that line, right? Or actually, you could do it like that, and you could find the value of gravity. However, you can also plot the position versus time as it is, and then use a quadratic fitting to find every factor of the parabola equation. All right? So let's see what the first part is asking you to do. You are going to use at least 6 different values of height, and you will need to measure the time it takes for the ball to hit the ground. And then you're going to plot distance in the y-axis versus time. Yeah, so this one you are going to be plotting y versus time squared. And then the slope of the line will give you the value of gravity. All right. Look, for the small ball, do not change the settings of the ball, of the mass and radius. For the large ball, you have to change it. It won't matter, but still, I want you guys to try that. So you will do the experiment twice, and then you will go to the second part. To measure the time, for example, you want 6 different values of height. So you can start with 20. Then you can go to 25, 30, 35, 40, 45, 50, and maybe even 55. Okay? So you start with 20. You want to do this at least 3 times. Oh, stop. Pause. And then you want to look at the last data point. So that looks like 2.06 seconds. All right? So in Excel, you are going to plot time and height. Why not? Let's put height. So 2.06 seconds for 20 meters. Now, you need to do this 3 times. So let's do it 3 times for each height. Two point zero six. Yeah, so, I mean, because it's a simulation, I don't expect you guys to have. So the average weight 2.06. Then you want to go to 30. You can go to, or actually 25, right? 30, 35, 40, 45, 50, and 55. So I'm just going to use one of the measurements because the simulation won't give you a large uncertainty. Oh, actually, that's better. 2.3. So you want to stop it like I did right there when it touches the ground. Ah, 2.3, of course. All right, so let's go to 30. Well, 2.50. Of course, it's taking more time. And then 2.70. Oh, bad. Okay, that's okay. Here. 2.94. And then 45. That's fine. Let's read again. I think I know what the problem is. There. There, that's a problem. It's running 45. You want to increase this, so because now I'm running 45 meters, this should be more than 45. Now you can see the time it takes. There it is. 3.06. And let's do till 50 because I want to see how the graph will look. So you know what to expect. .23. Okay. Remember, just like in a lab, You may not be very precise. It's okay, times square. So this will be equals this guy square that. And then you want to drag this down like that. That's the square of the time. So we're going to plot this column with this. I ignore this for now. I just want to see the trend. You want to use a scatter plot. Very nice. It's what you will expect, right? It's almost a perfect line. And then you want to label the axis. So you want to have axis titles, position versus time square. This could be vertical distance or vertical position versus time square. And then you want to add your trend line. It's going to be linear. You want to display the equation in chart. And look, that's the slope, right? Of the position versus time square. But remember, y final equals to y initial plus v initial time minus 1/2, right? Gravity. So the slope is 1/2 of gravity. So we are going to multiply 4.7973 times 2, and you can approximate that to be like 9.60. Pretty fixed. So 9.60 is the value of gravity, my experimental value of gravity. 9.60 meters per second squared. So not bad. Not bad at all. All right. You will do the same for a large ball. And then you will do a percentage difference. That's part one. You have to show the graph. You have to show your table of data like I did. And you should discuss certain values of uncertainty and error, right? Of how you are measuring time, right? The simulation is sort of perfect, but not ideal to gather data. So there are some moments where I probably miss by a few decimals. So that's why I didn't get 9.8. Now, for an experiment like that, and the way I did it, it's not bad. The second part will be a bit more tricky though. All right. In the second part, you are going to use both position and velocity. Okay. You are going to drop just one ball in this case. You don't have to do it twice. And you're going to plot distance versus time and velocity versus time. So we reset this guy. You're going to click here and click here. And let's try one and then see how you have to graph now. What makes this graph or this section a bit more difficult is that you have to choose 6 different positions and 6 different velocities. And you see the coordinates here? You have to annotate. X is time, Y in this case is velocity, Y in this case is position. All right? And your data will look like this. For position versus time, and then velocity and time. And look at the graph I got. So this is velocity versus time. Look at the slope there. In a velocity versus time graph, the slope is the acceleration. So I should get the acceleration of gravity here. And that's pretty close. Not bad, right? Here is where it gets a bit more complicated. So let me show you how you will do the first part, and then you will know what to do for the second part. Here, I use a parabola equation because it's vertical position versus time. So you need to use a parabola, right? What makes this a bit difficult, this data here, this table here. Let's make it into a table. There. What makes this a bit complicated is that you need to really look carefully at the values of position and time. So let's see if what I did was correct. Yeah, so I'm gonna read this. This point here is 2.06 and 0. So that's the ground. That's the time, and that's the... So see, here should be 0. Huh? Now let's take a look at 1.9. So 1.9 should be with 4.05. All right, maybe I use different, but so let's just read this again. All right, so I choose these two. You don't have to go even. Like you see how I'm randomly checking, right? We can probably go to, okay, let's take a look what values I have here. 1.73. So 1.73 is there. That's 6.13. 1.53. Okay, let's change this. 1.53, 8.79. Oh yeah, perfect. 1.25. 1.25, 12.95. Not bad. 1.09, 14.8. 1.09. I'm looking at the X, remember. 1.09 is the time. No, because it's to the right. So 1.09 will be 14.22. And then 0.73 is very close. Yes. 0.73 is 17.69. All right. So now I'm gonna plot this. And you should see again with the scatter plot. Make it bigger. So doesn't matter if there's space out. It can be part of why it's not gonna be very precise. It's okay. And your trend line should not be linear, of course. It will be formal trend line. It should be a polynomial grade order. All right. So we raise the first one. It doesn't really go through the points very nicely, right? That's because there is some error here, right? How we measure this, how we read the data. But you display the equation in chart. And again, the quadratic coefficient, the linear coefficient is the initial velocity, which again, if you think about it, should be 0. So that's not exactly 0, right? And this is initial height. It was 20, I got 20.5, 20.46. So this will not be exactly. So again, 1/2 gravity times square. So this will be half of gravity. So let's see if I multiply by 2, it will be a bit off actually. Yeah, 8.6. So it's a bit off. So in this one, it will be a bit off. All right. The objective of this exercise is just to show you the nice quadratic relationship. You can get a bit closer. It's just how you read this data. For the time versus velocity, however, that's the data there. Make sure, remember, it's negative because it's going down. So don't forget the negative. If you plot time versus velocity, even though they look a little bit spaced out, the trend line will be linear in this case. And look at the slope. Very close. Closer than what we had here. So you just have to do this once. And then you can start doing the last section of the lab, which is, well, these are the tables for the first part, for the second part. And yeah, you just have to discuss the methods that you use to find the value of gravity. Okay. Don't forget to do the percentage difference. And don't forget to ask questions if you have any. At the end of the day, you may have questions about how to read the data. All right. And again, if you have difficulties with the software, please let me know. Okay. All right. So this will be another video, will be uploaded this in Canvas, and make sure that you go through it when you are doing this lab, okay? Everything is perfectly clear in the instructions and in this tutorial.